So keep the profanity to a minimum. Now, effectively, I thought it'd be pretty funny to kind of look at the protagonist of the Doom video game series, and specifically basing it off of values of what I've been able to see from information through the internet, hence why you see my references over here, and which is really awesome because some guy actually already figured out what he thinks the peak speed of the Doomslayer happens to be in miles per hour, which is literally 49.5 miles an hour, which is awesome because that makes a lot of other things really, really easy to figure out. So from there, we just need to go ahead and have a lot of fun with math. So the Fick equation is effectively telling us that our cardiac output equals, or multiplied by our AVO2 difference, gives us our total oxygen ability for uptake. So we figure most folks, when they have that mixed venous blood, is about 40, whereas whenever it's fully saturated, it's about 100. So you figure they're extracting 60%, which in reality is probably not going to be that efficient here. And we figure if the average person has a resting cardiac output of 5 liters per minute and can go up to 12 or maybe 25, if we're talking about a really, really high level athlete, this would put the cardiac output for the gentleman in my example to be absurd, but freaking awesome, because in theory it would be somewhere around the tune of, we take that initial VO2 max number, and now we need to go ahead and effectively divide out that AVO2 difference, which ends up being about 60. And sweet Jesus. Then we need to then take, I'm going to go 80 because we need to go a little bigger than that. But the other thing that I'm not adding in here is that's not the total blood volume that's being sent around. That's the percent of the fraction that happens to be oxygen. So that was what I was trying to look up initially before you guys hopped on the line. So hence why I am just going real, like low tier, just using the powers of the Googles to figure out what I think is going to be a pretty good. You're not useful to me. 15. So there you go. So yeah, so it's about a 5-to-1 ratio going off of oxygen transport. And it turns out I kind of expect this to be a little bit more accurate. Okay, so here's the Fick equation again. Okay. Okay. So there's the millmercury. Oh. So we need to convert from grams of hemoglobin per deciliter is going to be the values there. So, okay. So if we figure that's 15 grams per deciliter and it can hold 1.2 grams of oxygen, then that means we're going to be talking about a 1. Holy crap, these numbers get insane. I love it. So that's going to be the equivalent of 1.2, and then we got to convert to deciliters, so we've got to go ahead and now times that by 100. And then we're dividing by 80. Let's see how our numbers are looking here. Yeah, that's pretty damn insane. Because that would be the conversion to get that into liters per minute. So then, in order to get our stroke volume, all we gotta do is take our cardiac output and then go ahead and divide that by our total beats per minute. Oh man, that's funny. It's a normal stroke volume of about just under 3 liters of blood per beat. And I was 6'2" tall guy. Awesome. And from there, that's the total loadout in theory in poundage. So to figure out the peak power and power relative to body weight, I'll figure out a jumping equation for this later to get an idea for the vertical jump. So it effectively, right here, is going to be the Harmon equation. And so what I'll have is it's going to be equal to that body weight multiplied by the height. Oh, wrong down here. Jump and the mass of the individual for peak power. And so then in order to get that into body weight, I'm just going to take what will effectively be my conclusion here. So it'll just be the peak equals the peak power divided by the body weight of the individual. And of course it doesn't like that. Let me go ahead and give me a few spaces so it won't freak out. And so max strength, I can figure that out. Strength to body weight, that'll be like the maximal load or anything else I can kind of figure. And then strength cross-sectional area, then we're just going to base that on build of the individual. And then all these other parts I'm going to go ahead and fill in later. But, So let's see here. 1, 2, 3, 4, 5, 6, 7. Then that'll be 8, 9, pretty easily done. So, sweet. I would have just gotten 4 points of extra credit for what took me about 17 minutes. So, what questions do you guys got for me? What do you guys want to review? What do you guys want to talk about? Can you guys even hear me?
Yeah, I hear you.
Okay,
Yep.
So you guys feel like you kind of got everything down pat? You're not going to have any issues with anything on the final? So we could just have you guys all take it and then I can be done with the grading for the class sooner than later?
Well, for the final, it's just the first season, right? Or do we have to jump into season 2 if we're doing it by the series?
Ooh, I like where your head's at. Once again, it's just based on some of the key or one of the key components of the show Altered Carbon, in that effectively what happens is the main character, anyone in that reality can effectively be pulled out of a body they're in and put into another body. So hence, if you really had that type of flexibility and we could apply that to very specific endeavors, both trying to perform in athletics or, any other type of arena, there's going to be a give and take to everything. So kind of like in this given situation, what would arguably be the most advantageous body effectively to be operating in that type of environment? So, it's not obviously LeBron James. Like, no, if the goal is to see who can fit through the smallest hole in the wall, you would obviously want to have the body more like a gymnast. If your goal is to be able to produce the greatest amount of just straight out force, yeah, you'd want to have a body more like a professional strongman. But at the same time, those professional strongmen are probably not going to be that great at a sport like American football, much less at a sport like wrestling. And then even less so, obviously, at things like just sprinting on a track. So with that information, what would we be trying to make a decision with as far as what would we select for, what would we want to try to take advantage of. So it's kind of being mindful of all the different systems of the body and how they can each play into what we're looking for.
Okay, that makes sense. So it has nothing to really do with the protagonist or antagonist as much as the ideas of the show.
Bingo, bingo. So if, tomorrow you could do a hard reset and literally just wake up in another body, and your goal was to have a body that would naturally be a really good 800-meter runner, what would you look for in we'll just say the muscle physiology? Like, what would you look for? Let's start off with just the energy systems. I'm listening, guys. I'm just gonna grab my water.
Maybe like anaerobic glycolysis.
Yeah, an 800-meter, specifically on a high level, a super high level, is going to take definitely less than 2 minutes. I don't know if anyone's done it in less than, I doubt anyone's done it in less than a minute and a half, but I imagine there's definitely been somewhere in that range. So yeah, that's really hard, anaerobic glycolytic. But what's going to be the other major energy system? It's going to be the other major energy system there. ATP PCR isn't a bad statement. Remember, that's only going to last us usually about 5 seconds, 15 seconds on the really, really high end. But for the most part, you're going to run that through pretty fast. So what do you guys think would be the next energy system to really try to bone up for the best of our ability?
Beta oxidation.
Okay. Beta oxidation isn't a bad idea again, but obviously only 4 of them. But that one is going to be a much slower production of energy aerobically than which one?
The ATP.
Or that's anaerobic.
Oh, so the aerobic glycolysis.
The aerobic glycolysis, exactly. That's going to be the other one that's probably going to really help us with really just turning over those calories fast enough that we're going to be able to hopefully be able to keep up that work output. So now, okay, we say we want those to be better. What does that actually mean on a cellular mechanistic sense that we need to have enhanced in those muscles in order to improve those energy systems?
It'll change the way we want to train that athlete.
Yeah, we're really trying to avoid the training. We're just trying to just strap into a body that's going to be better for it. So
I guess we would want our muscles to be able to like get oxygen faster.
okay, and what could allow a muscle to get oxygen faster?
Crap.
Feces usually doesn't help with metabolism, though. Removing enough of them will make you lighter and increase your power to weight ratio, which would technically make you a better athlete. Plus, nobody really wants to have to fight someone covered in their own excrement. Okay. Any of the Abbeys or Brent, what do you guys think would be the major way we can make sure that that muscle fiber can get more oxygen? What's going to help us out?
Are you asking like from one of the four, like glycolysis, ATP, PCR, or just in general?
So you have to think about what's pushing those changes and what's allowing those energy systems to work better. So it's not just that we can name them, it's what's going on under the hood that allows them to function on a higher level. And so Jake started off with, well, delivering more oxygen to those fibers. How do we deliver oxygen to a fiber?
We would have to increase the like capillaries, wouldn't we, for the blood flow?
Yes, the capillary to fiber ratio or fiber size ratio. Good. What else is going to help us deliver more oxygen to that cell? Specifically, it's mitochondria.
Whoa. Hmm. Would it be more the
I'm sorry, Jake, you cut out. I couldn't hear you.
yeah, my internet's being crappy.
That's okay.
I said increasing like the amount of mitochondria. I don't know if that's right, but
Now, that's going to definitely help with aerobic metabolism, 100%. That is not a bad thing. And specifically, which two parts of aerobic metabolism are going to be enhanced by increasing mitochondrial number?
the ATP, right?
No.
Oh.
I mean, it's going to help us produce more ATP, but specifically, what energy, what parts of energy production occur in a mitochondria?
I'm not sure.
That's okay. I appreciate you giving me something. Brent, what do you think it is, bud? That's what we're trying to generate is ATP, but what is the names of the processes that are producing energy in the mitochondria? We just hand mitochondria oxygen and then it spits out ATP and we're all like, woo, yeehaw, let's work out. Now you guys are naming energy systems. You're not actually naming what's occurring inside of the mitochondria.
Is it the Krebs cycle?
Yes, the Krebs cycle. And what else?
Glycolysis? Oh wait, that's a
Glycolysis occurs in the sarcoplasm.
yeah.
And yes, cellular respiration occurs in the mitochondria. What do we actually call that process? Gluconeogenesis is when we're making new glucose, specifically in the liver. How about the electron transport chain, guys? So it's not just increasing our mitochondrial number, but it's also increasing the enzymes related to glycolysis in the sarcoplasm, so we can get that to go faster. That's going to help for both anaerobic and aerobic glycolysis. And then we can increase those rate-limiting enzymes for the citric acid cycle and for the electron transport chain. Does that make sense to you guys?
Yes.
Lost.
Okay, who's lost?
Jake.
Okay. In what way?
Can you go like just repeat what you said? Because I was just kind of confused for a little sec.
Okay. So when we're looking at improving our ability to utilize these energy systems, it's not like we just say, I want to have better insert this energy system. Well, you need to have better infrastructure that allows those energy systems to occur.
Mhm.
That means we need to increase either the total amount of supply or store of that particular precursor. So for both aerobic and anaerobic glycolysis, that's going to be storing more glycogen inside of the muscle. Then we need to go ahead and increase the enzymes related to those energy systems. Because remember, guys, enzymes can only perform their action as quickly as possible, but there's going to be limited on how many of those enzymes there are. So what we do is we increase the enzyme number. And that's equivalent of having more workers so we can get more work done given the same period of time. On top of that, when we go into the aerobic energy systems, in order to get them to run faster, we need to increase our number of mitochondria, which is also going to help increase the number of enzymes related to the citric acid cycle, which is where both fat, protein, and carbohydrate all feed into. But really, it's fat and carbs that we really care about with performance. And then all of those products are going to feed into the electron transport chain, which is going to finally give us that ATP. So it's understanding what's the mechanism, what's going on that's actually causing these changes to occur that's going to give us these hopefully positive adaptations. Okay, so if I lost you at some point, where do you feel like you kind of lost the plot?
I got lost kind of around when we started talking about the mitochondria and then like what they help produce.
Okay. So, okay, let's just start off at the beginning. enzymes. What do they do, guys?
Um,
What's an enzyme do?
Speeds up chemical reactions.
Okay. Speeds up chemical reactions, and that is almost a slight disservice because it causes chemical reactions to happen that might not happen otherwise. Okay? Everyone with me there?
Mm-hmm.
Okay. So now, if I have one enzyme, okay, and that one enzyme, okay, we'll say can take and we'll say cut a piece of paper in half each minute. After 60 minutes, how many pieces of paper will it have cut in half?
$60.
So now I'm going to take, and instead of having the one enzyme, I'm going to get 4 more. So I have 5 total enzymes that each can cut a sheet of paper, 1 per minute. After 60 minutes, how many pieces of paper have I cut?
300.
300. Now the same is true of how we're producing energy. So instead of cutting a piece of paper, it's cutting a carbon bond or a bond between 2 carbons in a glucose molecule, or it's adding a phosphorus, or it's adding a hydroxyl unit or removing a water, any of those. So if I have one cell that only has one enzyme each for all of those 12 steps of glycolysis, and then I have another cell that has 2 enzymes for each of those steps, how much faster is that cell going to break down glucose?
Twice as fast.
Bingo. So that's why we want to increase the number of the enzymes that are related to the energy systems that we're trying to use. Does that make more sense now, guys?
Yes, and then for the carbs, they have to be broken down to be like monosaccharides before they can be used to energy. Is that right?
Yeah, they remove one glucose molecule from glycogen. So it's a 1,6 carbon sugar that gets utilized, and then that'll go through metabolism and follow the processes. So it can't just feed in, a super long chain. It has to remove each individual glucose at a time.
Okay, that makes sense.
So if you think of, the enzyme number as, once again, how many people we have cutting paper, think of the mitochondria as to how many factories we have that are running the same process. And so if we can have not just more people working in the factory, but at a certain point, you max out however many people you can have in one factory. So then if you want to keep producing things at a higher rate, you need to build more factories. And so those more factories turn out energy even more so at a faster rate. Everybody with me now?
Yes, sir.
Cool. So Now, what other questions, comments, concerns can I help you guys with when it comes to that energy production side? And maybe myoglobin, increasing that to help transport that oxygen to the mitochondria from the blood. And then obviously having a better oxygen carrying capacity and having a better cardiac output, shipping that blood through those capillaries. All of those are going to add to better performance with the aerobic energy systems. This picture should be up there somewhere where you guys can see, and I put the video also online that you can look up, where I literally break down kind of the big components of each of the chapters. And then we can see how I, obviously go through different stages of beard. Anything else you guys would like to go ahead and talk through? All right, well, let's start getting people to ask me questions. Sierra? Well, here, Sierra's gonna go first, so this way she can think about it for a second. You're either gonna ask me a question about the class or I'm gonna ask you a question about the class.
I'll ask you.
Sounds good. What's your question?
Well, it's not really like a question. It's a question about the final.
Mhm.
Do you want us to use the show as like a reference or just an idea?
No, it's giving people the idea of what's going on. You technically don't even need to, you don't have to watch the show really, just understanding that basic concept of being able to body swap. So, there's a number of things that are it's important concepts to think about, which is if, let's say for the sake of argument, like, oh God, was it the Freaky Friday movie back in the day where they switch bodies?
Mm-hmm.
So now imagine the sheer terror that both of us would go through if tomorrow you woke up inside of my body and I woke up inside of yours.
Mm-hmm.
Now, what do you think is going to be the first thing that you really notice, like when you get up?
Body parts.
Yes, body parts. Well, let's be honest. One of the first big differences, as soon as you can see yourself, you're going to be like, dear God, I look pale. And then realize like, oh dear God, this isn't me. And kind of the same thing where I'm like, is the room that dark or am I, like that would be a big difference. But think about the weight of the differences between our two bodies, and also the flexibility differences and the mobility differences. And on top of that, literally the length, aka the height differences. So how tall are you, Sierra?
5'7".
Yeah, so you're only 2-3 inches shorter than I am, but I also don't think you've got freaky long arms and long legs for your height
No.
to the same degree that I do. So one of the bigger things you're going to notice is like you're going to knock things over because you're not going to be used to being able to reach that far away. And whereas I'm going to be like trying to grab things and be like, sweet Jesus, why can't I get a hold of anything? And then, obviously our hands are different size, our feet are different size. And then our center of gravity of how we naturally balance our bodies in different spots. So we're probably both going to be walking around like we're drunk for a little while simply because we're not used to operating that body. Does that make sense?
Yeah.
So what do you think would be some other differences that would be, aside from the fact you'd wake up and be like, Jesus, why do all of my joints hurt? But what do you think would be some big differences just between, once again, the difference that you and I have for body size?
Like appetite, how much you eat.
Good job. Because you're probably gonna be like, why do I never get full? Like, why do I just keep wanting to eat everything? Like, exactly. Whereas I'm going to, be like, I don't really know how ravenous you are typically or otherwise. And obviously we could both throw out a bunch of cliche things about what we think the opposite gender likes to eat as far as food. But no, that's definitely going to be a difference. Now, obviously, when it comes to then trying to play any sports or anything, the first thing I'm going to probably notice is like, man, this body is light, like changing direction, climbing stairs and everything else. Like, this is pleasant. Whereas depending on which day you occupy, you know, my body due to soreness from the day before, you'd be like, what, did I get hit by something yesterday?
Yeah.
So you see how all those considerations are going to play into kind of how you would actually operate literally a different physiology from your own.
Mm-hmm.
So it'd be naturally disorienting. Probably wonder why can't I keep looking up? And then you're like, oh, it's because I have traps and my head keeps hitting the back of it. So, no. But does that kind of give you a little bit more context and kind of
Yes.
other ways to think about it?
Yeah.
Awesome. Okay. Thank you, Sarah. Oh, awesome. And she muted herself. Perfect. Courtney, I know you kind of jumped in a little bit on the chat, but anything? Let's see if you got a question for me.
Just wondering, like, if on Friday when we do like the questions and stuff like that, if you would review the energy systems, because I still really don't understand them all too well.
Okay. Yeah. I mean, turns out literally all this week and next week is meant to be is just review. I mean, we've gone through the material because obviously since we didn't have the normal lab, I've just been lecturing more because it turns out I'd rather keep giving you guys information than trying to give it to you in as many different ways as I can, since we don't have the same normal classroom interaction, which is, it puts some challenges on both of us. Both of us meaning myself and the teacher, and then collectively all of you guys as students. So this is just an important slide to understand. So I got the chapter 2 slides up where you can see effectively the interrelationship of all these different energy systems and how we're going to play in from one to the other. And then really just kind of going through understanding, we're only producing as much energy as we need. Enzymes allow for the catalyzation of different reactions. So thanks to them being there, those reactions can occur far more easily in that they either don't need activation energy or they greatly diminish the activation energy. Okay. So ATP is the major energy currency of the cell. So we're always trying to replenish this. And then obviously the different systems that we're using to build things up or break them down. So the ATP PCR, anaerobic glycolysis. And notice, guys, we're talking about that rate limiting enzyme. So when we increase the number of this, in turn, we're going to be able to run more glycolysis in the sarcoplasm. And then the same is to be said once we get into the mitochondria, where we have the Krebs cycle and the electron transport chain occurring. And that's where we're going to see like citrate synthase and succinate dehydrogenase, both inside of the citric acid cycle, aka the Krebs cycle, which when we increase that number, it tends to increase performance. So take a look at these slides, Courtney, and then come with some direct questions either tomorrow or Wednesday or Friday, and we'll go ahead and talk through those. So Emily, you can ask a question if you want. Otherwise, I'm going to pick on Hadley because she's been quiet.
I think I have one question on slide 6 on chapter 2, just about, I don't know, like if this isn't specific, you can just say no, but the relationship with creatine and the enzymes chart.
So which one? Here?
The top one. Yes, that slide.
Okay, now, so creatine is effectively giving us more of the precursor we need. So actually what we need to do is come to right here, okay? Because we have phosphocreatine, then gives up that phosphate, which is then transferred to a ADP to turn it back into ATP. They're not cute very often, so whenever it happens, I need to try to get evidence of it. Sorry, guys. Okay. But by supplementing with creatine, you're increasing the stores of phosphocreatine in recovered, or essentially in a cell, So that way we can donate more phosphate to ADP to regenerate that ATP. Now, the enzyme that catalyzes that reaction is what comes up on the next slide, and that's what's known as creatine kinase, which is also sometimes looked at as a marker of inflammation, because really hard, stressful training increases the blood levels of it, but it's not the best proxy of, it gives us a little bit of information about muscle damage, but it's important, obviously, for making that reaction occur. And the cuteness is over. Good. Does that answer your question, Emily?
Yes, that does. And then in relation to what we talked about last week about supplementing creatine, so how does that change the breakdown of the catalyzed?
It doesn't change the reaction whatsoever. It just gives you more effectively of that fuel in your muscle's fuel tank.
Okay,
Yeah, you've got more that you can draw from.
gotcha. That makes sense.
Okay, Hadley, what question you got?
Can you hear me?
Yep, what's up?
Okay. So this one goes back to talking about steroids like we did last week. What's the difference, or like, is there a difference between the steroids that people take to get like bigger and the steroids that doctors prescribe for like treatment?
Okay, now remember, actually, this goes all the way back to actually chapter 4, in that effectively a steroid is just a class of hormones. Now, when we're talking about using anabolic androgenic steroids to enhance performance, those are things that are related to testosterone. Estrogen and progesterone, so estradiol specifically, is also a steroid hormone. But if I take that, I'm going to start to develop gynecomastia, and along with changing up how my body distributes fat subcutaneously, along with probably, it's probably going to help improve my insulin sensitivity and probably decrease my risk of heart attack. So, you know, have to start wearing a bra, less risk of heart attack, you know, pros and cons. But that is still, once again, a steroid hormone. Now, when you go to the doctors for having like a bad allergic reaction or some type of inflammatory issue, you're sometimes given corticosteroids. So those effectively are analogs for cortisol, which is obviously that stress hormone. That prednisone is one of the more potent ones in that area. That is going to cause your body become insulin insensitive, so insulin resistant, along with usually making you feel loopy and otherwise not good. So it actually causes a decrease in performance. So saying somebody is taking steroids, a lot of I don't know, guys, I would wager a guess that a number of the ladies currently in this lecture, or at least obviously in your guys' age group, are taking steroids as a means to not necessarily just for only birth control, but also sometimes to just improve symptoms of PMS, menstruation, and then sometimes things like acne. So it's just a class. It's then specifically what we're using from that class that has an effect.
Yeah.
Kind of like how caffeine's a stimulant, just like cocaine, but I think we're a lot more comfortable with handing out caffeine compared to the cocaine.
Gotcha.
So both Jakes, you guys, if you have questions, go for it. Otherwise, don't worry about it because you've been good with asking questions today. And then we'll go down to Lewis.
Yeah, actually, just got a quick question.
Yeah, what's up, bud?
Yeah, we kind of went over this subject really fast in probably the last chapter, and you said that there's probably like some speculation about like fasted training. Or like, does it actually increase performance over time, or is it just a social fad that people have out now for fat loss?
Great question. So in reality, guys, the way you lose weight is always going to be the caloric deficit. Now, by however you put yourself in that deficit and keep yourself there for a long enough period of time is the key. Now, for some folks, that whole, fasted cardio, like, yeah, that can potentially be useful in very specific cases. And by specific, I mean in a glycogen depleted state when you're going to do like long, slow distance. So it's just obviously very aerobic work. You're not really trying to tap into that anaerobic metabolism. So in theory, it might give you a little bit of a boost with those improvements to both aerobic glycolysis and beta oxidation by helping your body increase your mitochondrial number and then the enzymes related to those systems, along with obviously the citric acid cycle and the electron transport chain. But it's not a really big difference. Now, the big like double-edged sword of it is if we have you do something like high intensity interval training while you're fasted, now you don't have the same amount of glycogen in your cells, so that you're not going to be able to utilize as much aerobic and anaerobic metabolism of glycolysis, which is going to cause a decrease in your performance in that given endeavor, and also is probably going to not give you enough of effectively an adaptive stimulus for that anaerobic threshold, or at least definitely like lactate tolerance and lactate clearance, which is actually caused mechanistically by what's known as monocarboxylate transporters that literally are what allows lactate to leave your muscle cells and then go into other muscle cells and or go into the mitochondria and then be turned back into pyruvate, then acetyl-CoA, and go through aerobic metabolism. So you can do fasted cardio. The key is, once again, it's whatever puts you in that deficit, whatever that method is, as long as you can keep it up and it's not hurting you, then by all means do it. But like anything else, you get people that love to be evangelical about like, this is the only way to do this thing and this is the only way to do that thing. I obviously take the scientific approach, which is there's a myriad of different ways you can go about it. The key is you got to figure out what works for you and your lifestyle. And some folks know that if they try to eat before they go on a run, they're going to cramp up. So yeah, I guess you got to go into it fasted. Like, so be it. Or you got to have like a super light meal. And then, other folks, like if you're trying to be a really high level athlete and specifically trying to carry around like a large amount of muscle mass or anything along those lines, and especially getting back to what Hadley asked, you're not using testosterone and other analogs to kind of bolster your performance, then I would definitely suggest making sure that you're staying on top of getting in all of the calories you need so your body is going to be able to recover as quickly as possible or to be as fully prepared as possible for each training session.
All right. Thank you.
Thank you, Jake. Lewis hopped out before I could ask him a question. So I guess we're going down to Taylor and then Tori.
Okay, yeah, I had a question about the female athlete triad, and I was just wondering how you would prevent things. I mean, obviously, you could prevent eating disorders. There's a variety of ways to prevent that, but how would you prevent things like, and I don't know if I'm saying this right, but amenorrhea, is that how you say that?
Yeah, amenorrhea. So, part of it is having an honest conversation with your athlete, and obviously, it depends on the age. So it's a difficult thing in that it's a number of societal expectations. So you can be, first and foremost, what you can do as a coach, trainer, physician, anything along those lines, is just follow a good basic edict for life, which I try to follow, but I'm not the best at, but I promise you guys, I try. And that's just, don't be a douchebag. So with that idea, irregardless of the size of your athlete, it's never using that as a point of shame, never trying to encourage any type of change that is going to be deleterious to their health and or change at a rate that is going to be deleterious to their health. So yeah, there are people that they need to lose weight in order to be a healthier person. And specifically, if you've got a kid, meaning like we're talking middle school, elementary, any of those that would already be easily classified into morbid obesity by body fat, just getting them to be physically active and getting them to make sure that they're getting a good relationship with food, a good relationship with their body, with physical activity is great. But then also understanding the realities of how they're built and effectively, you know, just feeling as good as what you have. Like, yeah, I wish I was 6 feet tall. And that's just not going to, well, technically it could. We could break my legs and then put me in traction, and then my legs would be even more stupidly oversized in length for my height, and I'd have the 6 feet. But it's just, that's not a good call. Like, that's not something that's going to make my life better at this point. And instead, it's just, you know, you have to deal with it. And I know that's a very simple thing, and that's different for other people, because obviously a lot of folks have a lot of other challenges. And we have a lot of societal pressure that gets put on us to be certain sizes, specifically, you know, cliches about being a male athlete is closer to obviously what I've found myself working towards. And then cliches about being a female of, you know, trying to be smaller. And so making sure that you're not instilling this and still instilling them to, once again, be healthy, be happy, and the other activities of their life they're doing well with. So when it comes to ways to avoid it, the better you can track your athletes with simple things like a vertical jump with, and I know obviously there can be, you have to be careful with how you approach it, but doing just body weights on the athletes, so that way you're knowing consistently that they're staying in a certain area. So as soon as you get that gal or that guy that has effectively hemorrhaged, you know, 2, 3, 4% of their body weight, and that wasn't the goal, to immediately sit down and have that conversation on what's going on. And then obviously with the female, with the amenorrhea, is after they've hit menarche, and also you're working with the population where you can ask these questions and not lose your job. So obviously there's certain areas that love to, I mean, gosh, I don't want to start too many fights that are too easy, but I'm making a straw man where, like, how many of you guys, ladies, would have been comfortable talking about your period with a male teacher or coach when you guys were in middle school? Like, what number is that?
Probably not.
Probably not. Okay. And that's okay. Like, because that's how we're socialized. That's what we are and aren't comfortable about. It's the equivalent of, you know, walking up to somebody and be like, hey, how much money do you have in your bank account? Or, you know, what's your thoughts about something incredibly polarizing that's political or religious or otherwise? Like, you know, there's just certain things that can be a little taboo. But at the same time, and Tori, I'm going to pick on you again because you're here, and I guess you're now the only person on the softball team. But do the athletic trainers ever ask you guys about, you know, your monthly cycle, the regularity, and anything along those lines?
I haven't been asked, but our trainer's pretty good about like talking about stuff like that with us. So if you're having issues, maybe.
There you go. So it's not necessarily like we need to like have like the calendar that we know, well, insert this athlete should have had it happen by this day, insert this athlete should have started by this day. Instead, it's, yeah, exactly that. Everyone has their own cycle. Hopefully it's regular for them. If it's starting to lose its regularity, it's a great indicator that your body isn't fully recovering, and you're going to quite possibly start performing at a lower level. And if you keep going in that area, then you risk really getting hurt. So it's obviously education, and then giving forth that information in whatever method is still going to, you know, cover yourself, but make sure that they're going to be safer if possible. And that's where, you know, the third option of the osteopenia, getting osteoporosis, that's what's great about our lab, is we can have the athletes come in, we can look at that bone mineral density. Because we've had a couple female athletes that they were already relatively lean, but they got even leaner, like significantly leaner, but they gained muscle mass while they lost fat mass. So even though they were effectively the same body weight, which was a small body weight for that frame to start, and they went from being lean to being pretty darn lean, they had gained lean mass. And based upon conversations, because, you know, I talk with the athletic trainers, and we make sure we're tracking the kids, specifically the ones that are arguably your higher risk cases, to be like, hey, you know, she says she's having a normal cycle. What I'm getting out of my lab is confirming that she's doing pretty good, because you can't really lie about your bone mineral density when you're laying on the DEXA. So whatever you can track and manage, then that's the thing to definitely have. But the key is, just because you can track it, if you can't manage that information, then you can get yourself into a weirder situation, because it's like, yeah, why did Taylor ask us about our menstrual habits a month ago, but we haven't heard anything about it ever since? Was she just trying to figure out if one of us was acting crazy for some reason and was trying to use some nonsense excuse? Or, once again, making sure that you can kind of build this stuff in so you kind of have an idea of what's going on. Does that kind of give you some ways to navigate that, Taylor?
Yes, thank you.
Awesome. And so, yeah, last but not least, Tori, you got any questions for me?
Just kind of about the female athlete triad. If a female athlete's like experiencing symptoms like that, but they're on birth control, would their period still be like irregular, or would that be like an underlying thing that was just like—
Great question, because that's a big issue, because a lot of females are utilizing some form of birth control, and some of them, like, they might only have a period once every 3 months, once every 4 months. So that's why tying it to performance is your best bet, because and this is, once again, this is running with a lot of social stereotypes, but a lot of people, even myself, if I woke up 10 pounds heavier tomorrow, I would be freaking out a little bit in my mind. But if I woke up 10 pounds heavier and I found that out after I went to the gym and I just dominated everything, like everything was easy, everything was light, I was just strong as anything, and I arguably like looked good, I would be like, yeah, you know what, those 10 extra pounds is fine. But how many of you guys, either yourself or you have friends, that if they woke up 10 pounds heavier tomorrow, irregardless with all those improvements in performance, you'd be like, oh my God, I'm 10 pounds heavier. Like, they would freak out in their mind. And, then potentially, stop eating and do those other things that can work against them. So you can sometimes have college athletes that they're now on those resistance training programs, which you gain muscle. When you gain muscle, you gain weight. When you gain weight, your clothes don't fit the same, especially since the aesthetic typically for women's clothing compared to men's clothing is usually much tighter. It's a lot harder on those folks, psychologically sometimes, to see that scale weight shoot up. And then same thing, they might be trying to force themselves to say the same size or be smaller because of, once again, stuff that we've had beaten into us by our culture since we were young. And so you gotta, yes, be wary, because they'd be like, I don't have a period because I'm on, whatever the thing is that goes into the arm. And so, I haven't had a period for 3 years. Like, well, that's no longer going to be a good indicator. But if you can get them on a DEXA or something else to do bone mineral density, like, you got that. But what's probably going to be your best bet in the first place is just tracking that body weight, tracking something simple like a vertical jump performance, and then tracking their effectively their own energy levels, performance, and kind of doing that holistic approach to life. So that answer your question, Tori?
Yeah, that sounds good.
Awesome. So yeah, great questions, guys. Thank you for asking. We're going to plan on kind of doing the same thing on Wednesday, and then kind of just rolling out like that for the rest of the semester. The final lab that Jake and Gracie decided would be a great time of doing burpees, that's now up on Blackboard, along with the Google Doc that's linked over to it. So feel free to go ahead and get started on yours whenever you're ready. Otherwise, be safe, guys. Miss seeing you guys in person. And please bring the good questions, because I really, really don't like talking to myself sitting inside my house for hours, because it's just weird. And Norbs doesn't really talk to me. He just barks and naps. But he's living his best life. So stay safe, guys. Miss you. See you guys later.